topic of managing animal nutrition. So how can nutritive value and intake be managed? Well, it's just how you manage your forage to produce quantity and quality, and that's what's going to determine animal performance. And as I mentioned in my previous talk, animal performance is defined by the amount of milk or meat produced from a given feedstuff. And grazing management is how we're going to manage forage quality and animal performance, because the goals of grazing management are threefold, and that's to increase the forage quantity. So we want to increase the amount that the animals have to consume. And we'll talk about something that sounds complex, but it's really not, the grazing optimization hypothesis, and how that relates to how you increase forage quantity. And the next one is to increase forage quality. This is the whole reason why you might till up a perfectly great native pasture system and plant and introduce species. The native forage is very well suited to livestock production, especially here where rainfall is limiting. But the introduced grasses are able to uptake fertilizer and convert it into more and a higher quality forage. So we might think about modifying the plant phenology and the tissue age. What this means is harvest time, the maturity at harvest. So we want to think about things like stem-to-leaf ratio and how mature the plant is when harvest. And then also modifying the species composition, and that's a long-term method of improving forage quality. So you might plant a new species, or you might manage your grazing to cause the increase in preferred species that are very high quality. And then a third way that we might use grazing management to enhance forage quality is to improve the harvest efficiency of that forage. So that means that a greater proportion of energy will go into the grazing animal instead of the detrital food chain. What this means is at any point in time, you're going to have some forage that's out there not being consumed, and it's going to die, and the leaves fall off, and it's called litter on the soil surface. And so the detrital food chain is pretty much the fungus that will consume that litter. So improving harvest efficiency means that more is going to the animal than to the other parts of the system. So our first item is forage quantity. And as I already mentioned, we have a warm-season grass-based system here in South Texas. And it's limited to late summer or spring through about 7 to 8 months of grazing is the time period that that's limiting. So we have around April, May when the warm season grasses are becoming green and lush, beginning to increase their growth rate to enough to support the animals. You're not feeding as much hay. And then in the wintertime, the growth is going to slow down. You might need to start supplementing the herd. And that's about 7 to 8 months that they're grazing and you're not needing to supplement for quantity. So as I already mentioned as well, the cool season legumes can extend the grazing season by 6 to 8 weeks, which reduces the time that you need to supplement. And okay, so I told you I'd tell you a little something called the grazing optimization hypothesis in regards to forage quantity. Okay, so here we have grazing intensity, and we have no cattle on a given piece of land. And we have a really high stocking rate here. And it's all relative. I'm not going to give exact numbers because it's really dependent on a lot of factors to determine your stocking rate. And then here's plant growth. And you can see that you have 0, which is your baseline. And as you begin to add cattle, the plant growth actually increases to the sweet spot right here. And this sweet spot is the point at which the plant growth is increased because it's being grazed And then there's a point where then plant growth is going to decrease. So this is a little counterintuitive. You wouldn't think that going in and removing plant would actually increase the growth rate of that plant. But that's how it happens. And the reason for that is primarily sunlight penetration. So you have the plant growing, and at the top of the plant is going to shade the bottom of the plant when it gets to a certain point. And so if you remove the top part of the plant that's shading it, it's going to allow sunlight to get to leaves and then a flush of growth from that plant. And so you can see here the shaded foliage here in this area is removed, and you have net photosynthesis, which is the conversion of sunlight into more plant, is going to increase. And this is the exact reason why, if you know anybody who has bought a piece of land here in South Texas and said, oh, I'm just going to have wildlife. Forget the cattle, forget goats, sheep, any of the grass consumers. We're just going to have wildlife. And that's why to just manage for wildlife, it doesn't necessarily work well, because you need to have the high grass preferring species out there to consume the older top material of the plant that's removing the area for shading. You're not going to maximize your forage production if you're not removing that material. But we get to that point where plant growth decreases because of grazing. And that is because you're diminishing your return. You need to have two things for the plant to regrow. And if either of these two things are not there, then your plant is likely to die and not persist. You need to have buds. So if anybody's ever done a cutting of, say, a rose bush or some other type of horticultural plant, ivy, I really like that. I don't know what they call it here, but the grass that grows in the shade, or it's not a grass. It's a plant that grows in the shade, but it has purple leaves. It's real viney. I like that because I think the purple color is stands out. So I just go and I cut it, and I make sure that the node where the leaf is there, and I stick it in soil in my pot on my front porch, and it grows like crazy. That's because that bud or that node is there. And there's nodes located on different parts of the plant, usually towards the soil surface. It's protected there. So if you have a stocking rate that is so high that that pasture gets grazed so low that it removes the buds, the plant cannot regrow. It has no place to regrow from. I think that Wayne Hill Silko used to call that lizard licked. So you don't ever want to see a lizard licked pasture, and boy have I seen some lately. But that means that's a real big sign that stocking rate is too high. And then the second thing is carbohydrate reserves. So you got to have the place for the plant to grow from, and then you have to have the sugar to actually allow the growth to happen. If you remove the leaf, it can't make any sugar from the sun, right? So you got to have sugar stored somewhere. And that happens primarily in the crown and the roots. And I like this picture a lot here. Continuously grazed grasses will have a small root system. Here, the more pastures are allowed to recover from grazing, the larger and stronger the root system is. So this is another benefit of rotational grazing. So here, this plant is allowed to recover. And you can see one thing that's really neat is that you can really estimate below ground biomass by what you have above ground. Kind of matches. And so here, you've got a nice healthy plant. Think about all the sugar that's in the roots that can be located up into the buds and really get that plant growing after it's consumed. And so the next thing that we're trying to manage for when we manage our grazing systems is forage quality. And it's a function of intake and digestibility. I'm sure that you all heard about digestibility. I mentioned it earlier in my talk today. And that's how much of that plant is actually used in the animal, converted into meat or milk. And then intake is the amount that the animal is consuming from the pasture. And you have to have a pretty high intake and a pretty high digestibility in order to increase milk or meat production. And forage quality is affected by maturity, and that also is seasonally based. So our warm season grasses this time of year in the winter are dormant. They're not very high quality. Also, fertility plays a role, and we talked about these things this morning. Your plant species plays a major role. The grazing method that you use, and also the animal species and the requirements. Different animal species have different intake and digestibility requirements. So this is a graph that shows how maturity at harvest affects protein and digestibility. So you can see here the blue bar is about 4 weeks maturity. And then we have 8 weeks maturity and then 13 weeks maturity. You can see that crude protein declines over time as the plant matures, as well as digestibility declines over time. The reason that digestibility decreases is because there's more structural components that the plant is making when it begins to mature, compared to the real soluble, dense nutrients like crude protein. So this graph kind of shows that. So over time, we have the amount of plant growth, the yield increases. At some point, when the plant gets too mature, the amount that the animal can digest isn't going to increase anymore, but the amount that the animal can't digest, the structural matter, is going to increase. So what this means is that the time that yield is maximized is not the same time that digestibility is maximized. And so you need to find, again, the sweet spot. And I use that because I really believe that forage science is an art and a science. So you kind of have to know and have experience and gain that experience and understanding of the plant and how it grows, how it affects the animal, to know the proper time to balance total yield and digestibility. And that's what good hay and hayers and grazers can do. So we talked about maturity, and that's the #1 factor that's going to affect nutritive value and forage quality. But then also, fertility management is going to affect that. So here, this trial, I'm going to just say 2 things about this. It was done in 1971. They were still learning a lot about Bermudagrass. Yes, 600 pounds of nitrogen per acre were applied. That is not going to happen. I don't expect you to go do that. But sometimes we do things in research just to find out what happens, and that's what happened in this case. Nitrogen was a lot cheaper back then. Okay, so we're going to look at our yield, tons per acre of Bermudagrass. This is a hybrid Bermudagrass. From when we apply 200 pounds of nitrogen per acre all the way to that 600 pounds of nitrogen per acre. And you can see it increases. Bermudagrass is really popular because of this reason. The more nitrogen it gets, as long as the other nutrients are there, the more it's going to produce. So you're always trying to make decisions based on economics and what you can apply, and then environmental considerations. You don't want that nitrogen to volatilize and run off. So crude protein in Bermudagrass is unique in that it increases as nitrogen fertilizer application increases. So you have a really high crude protein concentration whenever you apply 200 pounds of nitrogen per acre, and then it gets all the way up close to similar to what a legume might provide at that 600 pounds of nitrogen per acre. But please do not apply 600 pounds of nitrogen per acre. You're going to lose too much of it to the environment. So when we're thinking about when we harvest, balancing our yield versus digestibility, and things like crude protein concentration and yield based on our fertilizer that we're going to add, we need to think about what the purpose of this forage is. Are we going to feed it to a cow that has the highest nutrient requirement? Are we going to feed it to a dry cow that's mid-gestation that has the lowest nutrient requirement? Or somewhere in between? And what do these animals require in order to meet their needs? So this chart is a summary of the nutrient requirements of beef cows And we have class listed all the way from a 2-year lactating cow, virgin heifer, and a dry cow at mid-pregnancy. And the crude protein requirements, total digestible nutrient requirements, and then the ratio that's ideal to meet the needs of these animals. And you can see here I've circled mature cow that's going to produce about 10 pounds of milk is going to require about a 9% crude protein diet at about a 56% TDN concentration, and that ratio works out to 6.2. That's about what well-managed Bermudagrass hay is going to provide, or well-managed Bermudagrass grazing pasture. And so keep that in mind. You're not going to need to apply large quantities of nitrogen as long as you're maintaining the forage in a vegetative state that's actively growing. You're going to be able to meet that animal's needs. So how do we determine forage quality? I think that Dr. Dominguez is going to share a bit more about this. I'm just going to talk about hay because that's the part that I think most folks are having difficulty with right now because you're buying hay. You need to sample each cutting or each lot and have it analyzed for TDN, which really translates to energy, and then in vitro digestibility, and then also consider crude protein. But energy is primary whenever you're thinking about these cows. The approximate cost for a hay sample is about $10 to $35, depending on where you send it and what you have it analyzed for. But it's well worth it. You might have some hay that's so good, you don't need to add anything else out there for them. I mean, you might want to just for management purposes, but you might not have to. But then again, you might get a hay that has a horrible TDN where you're going to need to supplement some of their byproducts to them, like silage grains. So this chart shows that as the forage crude protein concentration increases, the dry matter intake is going to increase. But it's only to a point. So we need these animals to increase the intake of a highly digestible forage for them to increase milk or meat. And so to get them to increase intake, you can improve things like crude protein. So we have a really, really low quality, this is probably King Ranch Blue Stem that's been sitting there for stockpiled all through this winter. Or we have something that's close to 10% crude protein. That's maybe our Bermudagrass hays or Bermudagrass pastures. Once crude protein gets about 10%, the intake isn't going to be increased any further. So if you're feeding a 12 to 14% crude protein hay, which those are out there, or you fertilize your pasture very well and it's got a high crude protein concentration, you don't need to add a protein supplement for the cow. So we talked about maturity, we talked about fertility, and now we're going to talk about plant species and how that's affected. So this just summarizes what would be considered a high quality and a low quality forage. So our high quality is going to include things like legumes, alfalfa, clover, soybean, cowpea, lab. And then cool season grasses. Our small grains, oat, wheat, rye, orchard grass, tall fescue, those don't grow here because they don't perenniate here in South Texas. And then lower quality, such as our warm season grasses like Bermudagrass, pearl millet, sorghum sudan, and then all the way to crop residues like wheat straw, cotton stalks, corn stover. And in general, within these subgroups, the annual is going to be a much greater quality than the perennial. And this summarizes that further to actually compare the digestible dry matter of these forages. So here we have the warm season perennials, and you can see the maximum dry matter digestibility is around 65%. That's really high for these warm season perennial grasses. And then it increases as you move to warm season annuals, cool season perennials, cool season annuals, and then legumes, which have the greatest nutritive value and forage quality of any of our forages. That is why alfalfa is referred to as the queen of forages. It's a legume. So, to compare, legume is greater than annual is greater than a perennial in regards to quality. And as regard to yield, that's sort of similar. Annuals yield more than perennials in general. That's why you might grow something like a Sorgo-Sudan hybrid for replacement heifers. You've got real high quality to meet their higher nutrient demand, and then you've also got a very large amount of dry matter that's produced, so it's worth maybe planting that on a small acreage and harvesting it for them, or letting them graze a specific smaller area. And as far as yield comparisons for legumes, it really depends on plant morphology. So how the plant grows. Has anybody seen the bee wild bundle flower growing? It grows, it's a huge bush. It is huge. That's going to produce a lot of dry matter. Now, a lot of that stemmy, and the animals might not want to consume, they're going to select the leaf off that plant. But if you compare that to a clover, it's not even in the same ballpark. And so it really depends on the type of legume that it is. So, and then as far as economics go, a perennial is always going to be more economical than annual because you don't have to plant it every year. You have to buy seeds, you don't have to go out there with a tractor and actually plant it. So that just intuitively makes sense. So what about legumes? Legumes generally have a higher lignin concentration than grasses. Lignin is the part that the animal cannot really use. But legumes have a greater forage quality. The reason for this is because of the way the leaf grows, so the morphology of the plant. So if you hold your hand up and you spread your fingers like you're probably going to stick your hand on a piece of paper and trace it to make one of those turkeys for Thanksgiving, you can see that there's a lot of gaps. And when you have these gaps, the microbes in that animal's rumen can get in and use all the nutrients there. And then when it's a leaf, you've all seen a leaf on a piece of grass and how it's parallel. So they grow like this. It's not very much space for those rumen microbes to get in. And that's the difference. It's all about how the plant grows and its morphology. So plant forage and plant and forage aspects that affect intake, to summarize, are quality and quantity. And then there's also animal aspects that are related to intake, such as their metabolism. All of us in this room probably have a little bit of differences in our metabolism, how active we are. And even in general, at a resting state, some of us are going to use more energy than others. That's a lot of factors contribute to that. Age, which that's why you might manage replacement heifers differently than a 5-year-old cow or your calves. But then among animal classes, or among animal species, it's different. Sheep and goats are very small ruminants. They have a much higher metabolism than cows do. And then also you have things like distension, physical limitations of the rumen size. There's a very, very small opening in the rumen that allows digesta to pass. If you have something that is very low quality, it's not easy for those microbes to get in, it's going to take a longer time to pass. You bought that Thanksgiving meal, which I've said that twice now, maybe I'm craving pumpkin pie, but anyway, you have that full feeling for a long time after that Thanksgiving meal, and it takes a long time for that to digest. And that's kind of what happens with these cows. They need to make room for the next batch of food, maybe dessert. If they're eating some clover, that'd be considered dessert for a cow. But anyway, there's a physical limitation. And then there's also behavioral. They're doing some really neat work comparing individual animals and how many steps they take in a pasture to get to an area to graze. Different things like that. So, harvest efficiency in the grazing system. I already mentioned this. You can impact the intensity or the method. And then you can also harvest for stored forage, and that would include hay, haylage, and silage. So when we consider harvest efficiency, grazing intensity, and grazing method, the question comes up, can both gain per animal, so average daily gain, and gain per given land unit, stocking rate, both be maximized at the same time? And the answer is no. The reason for that is because when you have your stocking rate here and you're undergrazing, your gain per land area is going to be decreased. The reason for that is because you don't have enough animals out there. And then when you're overgrazing, the gain per land area is also going to be decreased. And the reason for that is they don't have enough. They don't have enough quantity. So then we consider gain per animal. And when you're undergrazing, gain per animal is going to be very high. And that's because that animal can go out and select all the green, lush forage. Now, I don't know that the animal is going to do that because it's trying to meet a certain need, but I do know that if it were my choice, I would rather be eating that green, lush forage than chewing on a piece of straw. And just for palatability reasons, right? And then when we decrease, we get to overgrazing, they're not allowed to select high-quality forage that's highly palatable, and they're also, again, not getting enough to support gain per animal. And so the art and science of grazing management comes into play, and you have this optimum range where you can balance and maximize both gain per animal and gain per land unit. You have to balance it instead of trying to focus on one or the other. And so when we consider that, we can consider that when we use our warm-season perennial grasses, the growth rate is highest from around this time of year to very early summer. And then it's going to decrease. And so you might be able to use rotational system to match this. However, if you're continuously stocked, there's no way to try to match your forage growth rate to your animals' per stocking rate. So warm season grass pasture systems do not maximize gain and or milk production. It's inherent because part of the year they're limiting in their quantity and they're also limiting in their quality most of the year. However, again, it's not always about maximizing the system. If we were to try to grow something else here or try to truck in all that the animal required as supplement or hay, then we're not going to be able to economically produce livestock. So when you're managing for forage, think about things like using the appropriate stocking rate so that you have enough forage to go around for each animal. And I mentioned earlier, thinking about the animal size. Size and how much that animal needs to live are very highly correlated. So really think about that. There are some folks that are buying smaller animals, and that's a really good idea. And then appropriate grazing method. So are you going to plant a specific species? Are you going to rotate animals to try to have the pasture go back to some of these really high quality or higher quality natives? And then harvest, be that either grazing or haying in a timely manner so that you can get that balance between dry matter yield and digestibility. And then use proper fertility and weed management, and that also helps you maximize the quantity and quality of your forage. So with that, I would take any questions. Time for questions.